We've been on simple algebra, and today we've been dealing with multiplication of algebraic terms. We have done addition and subtraction of algebraic terms. So I'll put the videos, the links in the description so that you can look up to those videos. But today we are dealing with algebraic terms, and I will be making this video a simple one so that everybody will understand what I'm about to teach. And there are terms that you've always perhaps even just crammed or something like 5x is equal to 5 times x. Let's see how this thing is true. A proof that 3x is equal to 3 times x. Now, you look at this addition relationship. We have x plus x is equal to 2x, and x plus x is equal to 2 times x. X plus x plus x is equal to 3x, and x plus x plus x is equal to 3 times x. Remember that 2 plus 2 plus 2 is equal to 3 times 2. 2 plus 2 is equal to 2 times 2. The same thing here, x plus x plus x plus x is equal to 4 times x. And in our addition of algebraic terms, you will recall that x plus x plus x plus x is equal to 4x. So if you compare these two relationships, you will deduce that 2x is equal to 2 times x is equal to x plus x. 3x this 3x is equal to this 3 times x, and it's equal to x plus x plus x, which is here. And 5k is equal to 5 times k, and it's equal to k plus k plus k 4 times, which is here. So when you hear us in math say 10 e is equal to 10 times e, we are not just forming things. You have now seen the proof that 10 times e means bringing e 10 times, and this 10e means adding e 10 times. So it has a multiplication and additive relationship. So when you see a letter and a number, there's always an invisible multiplication sign between them. 5k is equal to 5 times k. So if we go a step further, 11e is now 11 times e, and 12f is now 12 times f. So you take note of this. If you are new to algebra, you take note of this. If you are familiar with some algebraic terms, today you may have known the proof. You don't just, if you have always said 3x is equal to 3 times x, you have at least gotten a proof for it. So now we are going to go further to prove that xy is equal to x times y. Now we are going to be proving that xy is equal to x times y. Recall that 3 times x means adding x 3 times. That is also 3x. 4 times x means adding x 4 times. 5 times k means adding k 5 times. That is 5k. So the same way, just as a number multiplied to a letter means you are multiplying that letter, that number of times that is multiplied to it. That is how now we now put x times y. This x can stand for any number like 10, 20, but now we want to use a letter now multiplied to a letter. So x times y would mean adding y x times, which is xy, just as adding 5 times k means adding k 5 times, which is 5k. That is how adding y s times will mean xy. So this implies that x times y is equal to xy, and xy is equal to x times y. So you now find out that's what we always tell you in multiplication of algebraic terms. Anytime you see two letters like p, q, we'll tell you that it means p times q. There is always an invisible multiplication sign between them. Also, when you see a number and a letter like 16 p, it means 16 times p. if you see Z ROS, it means Z times R times X. So there's always an invisible multiplication sign between letters or between a number and a letter. We are starting from the scratch and we are going to build up from here so that as we get into higher algebra, when we say some of these things, it will not look as if in mathematics we just cook up things and we just come out and impose it on you that 16p means 16 times p. So in this my channel, I'll try to make sure that as high school students watch my maths videos, all those things you must have crammed, like for you may have crammed this type of thing, that you will now know why we say 16p means 16 times p. So there is always an invisible multiplication sign between letters or between a number and a letter. But it doesn't go for two numbers like 34. There is no invisible multiplication sign here. This is 3 times that is 30 plus 4, which is 34. So it doesn't work for numbers. It only works for a number and a letter, or a letter and a letter, or when they are plenty, like 6p a y. It can be 6 times p times a times y. A number must be involved or may be involved, then letters. There's always a multiplication sign between them. Even when we have an index form, we also put the square there. And I'll now tell you the meaning of this index since I've introduced it. When it comes to letters, what do you mean by this square or the cube you will see? So let's look at it, because I want to explain these terms before moving to multiplication of algebraic terms proper. Just as we have 2 times 2 times 2, that is 2 raised to the power 3, 3 times 3 times 3 times 3 to be 3 raised to the power 4. That is your normal multiplication. In your basic school, you must have seen something like this. 3 times 3 times 3 times 3 is equal to 3 raised to the power 4. This is called the index form of this multiplication expression. In the index form, this 3 now is called the base, while this 4 is either called the index or the power. This base is what is multiplying itself over and over, while this 4 represents the number of times that number has multiplied itself. So if you see 2 raised to the power 5, it means that 2 will multiply itself 5 times. That is what it means. 2 raised to the power 5 means 2 times 2 times 2 times 2 times 2, 5 times. If you see 2 raised to the power 100, this board will not be able to contain it. It means 2 times 2 times 2 up to 100 times. That's what it means. So you can see that this thing has helped to shorten you multiplying 2 times 2 up to 100 times. This is one of the advantages of using the index form. So of multiply something 100 times, you can say it is that thing raised to power 100, and this is 2 raised to power 5. So if you take this to algebra, if you have your a times a, you have your a square, your b times b times b, you have your b cube. You have your k times k times k times k times k times k. You have your k raised to power 6. There's something about this. The square and the cube. It is either called raised to power 2 or squared, or this one is raised to power 3 or cubed. They have special names. So if you see b times b is b squared, while c times c times c is c cubed. But from 4 upwards, we say raised to power 4, raised to power 5, and so on. So I'm going to be putting some expressions, algebraic expressions, in their index form now. Um, these are more algebraic expressions. This is p times p times p times p. That is p raised to power 4. And this is ax times ax times ax. That's ax. When they are more than, when you're using more than, when you're multiplying more than a letter, that is two letters over and over, you use your brackets to use your brackets. So this is ax raised to power 3. SYZ times XYZ is XYZ raised to power 2. So we have been able to put, because when we'll be doing multiplication of algebraic terms, you will meet where a letter will multiply a letter, the same letter. Like if it is x times v, this is xv. Or if it is x times v times x, that is x times v. So this is now s squared, you bring this one v, which is what we are going into to do now. So we've explained this square, and we've also explained why times is always in between letters. And if you have a number, this is times 5. We've also explained why there's a times between 5 and a letter. It just means, this means 5x squared v. But let's take them bit by bit so that you don't get confused. Let's enter into what we are doing, the multiplication of algebraic terms. We have 2 times 5 is equal to 10. 2 times 5 times k is equal to 10k. 2 times 5 times k is equal to 10k squared. See, it's progressive. Times k times y is equal to 10 times k squared times y, which is equal to 10k squared y. So if we starting here is 2 times 5, the one you already know is 10. We now say 2 times 5 times k, this is 10k. 2 times 5 times k, that is 2 times 5, 10. K times k squared. Bringing them together is 10k squared. 2 times 5 times k times y. This will give you 10. K times k squared. Y, this is times y times y. Then if you join this together, since you are multiplying, you just move these multiplication signs and bring them together. That is your 10k squared. So when you look at this 10k squared now, there's an invisible multiplication sign here. Invisible multiplication sign here. And even this k squared here means k times k. That means there is multiplication in this index. So you now understand when you see 10k squared, the makeup of this 10k squared. It means 10 times k times y. Here we have this I, c times times p times v. This 3 times a times s times a times 7. This 7 times a. This particular multiplication expression does not need any form of rearrangement, because you have c is coming before p is then the v. So this one you just go straight. Your I, solving this, you have c times c, that is c squared times p squared times v. So to join them together, you move the multiplication signs. Then you have c squared p squared v. Now, if we are to solve this, because of, you can see x and a coming, we'll rearrange the terms. So you have 3 times a, you bring another a, then you bring the s now. Okay, there is 7 here, no? I have 3 times 7. 3 times 7, that is, if you are done with the numbers, then you go to a times a times a times a, bring the 3 a's, then times x. So 3 times 7 will give you 21, times a times a times a, which is here, will give you a cube. A times a times a a cube times x. So this will give you 21 a cube x. You've seen why I spend time to explain your index, because I know they will come in, so that when we start, since we have started it now, I don't think it's a problem for you. So you know the makeup already: 21 times a times a times a times x. So let's go into another type, type of another format of multiplication. Then you take your assignment for the day. Um, this is another format. Let's take a 2x times 5. So in 2x times 5, you expand this 2 times x times 5. You arrange it, you bring numbers to numbers. You have 2 times 5 times x. So this gives us 10 times x, which gives us 10x. That is for A. If we go to B, we have 4 times 3y. That is 4 times, you expand this 3 times y. 4 times 3 now gives us 12 times y, and this gives us 12y. We have 3x times 7x. So if you expand 3x, you have 3 times x. Then this times comes here. You expand 7x, you have 7 times x. Then you rearrange the terms. The numbers will come together, the x will come together. So you have 3 times 7 times x. So 3 times 7 is 21 times x is s squared. So this will now give you 21s squared. So let's go to D. We have 8a times 3ab. And if you expand this, you have 8 times a times, you expand this, you have 3 times a times b. So if you rearrange it, you have a times 3 times a times a times b. So a times 3 will give you 24 times a times a is a squared times b. So this will give you 24a squared b. So with this, we've come to the end of multiplication of algebraic terms. Most of what I do is that before I teach my maths, you can see now it's as if I'm fast. I will teach you all it takes for you as to, have an easy flow in that math. So whenever like we start a math, like the next one is division of algebraic terms, I may be explaining some terms to you. Please, you pay attention, so that when we get into the division proper, all those things I've explained is just what will just play out. Within some minutes, we are done with the maths. But if I've not explained, for those that are just coming, that are just meeting this kind of maths for the first time, if I've not explained a square or a raised to power 5, you'll find it difficult when we are solving it. But having explained those things before now, you will find out that we have just, in how many minutes, resolved the multiplication of algebraic terms. Most of you are knowing me for the first time. I pray that very soon you will soon understand my method of teaching, and you find out that you will find math very simple. If you still have issues, go to the comment below and make comments. If you enjoy the teaching, make your comments. Do subscribe so that you always get the notifications when I post new videos. So right now, I'm going to be giving you a form of problems for you to solve on the multiplication of algebraic terms. Please do well to solve them. One thing with mathematics, we always say practice makes perfect. If you just learn maths without practicing it, before you know it, that maths will not be in your long-term memory. You may just enjoy it and say, oh, I can now solve algebraic multiplication of algebraic terms. It's still in your short-term memory. By the time you do this small exercise, you have taken that mass from your short-term memory to your long-term memory. Now you are now ready for division of algebraic terms, which this thing we've learned now will also come up there, because in division of algebraic terms, you first of all do a form of factorization before you do your proper division. So make sure you do your little take-home assignment so that you'll be prepared for our next class. Thank you. So I'll be posting it now. Then I'll just put the answers immediately. Don't look at the answers. Make sure you solve before you look at the answers and check whether you did well. Then if there are any, if you failed any, use the answer to correct yourself.